Hey everyone, and welcome. So, you want to supercharge your MongoDB performance? Well, you're in the right place, because today we are diving deep into the most effective indexing strategies to make your queries absolutely fly.
You know, it's a question pretty much every developer runs into at some point. Your app is up and running, but suddenly queries are starting to feel sluggish. You know you need to fix it, but where do you even begin? Well, the answer, and I mean almost always, starts with one single crucial concept.
And that concept? It's indexing. See, without an index, MongoDB has to do something called a collection scan. And it's brutal. It means it has to look at every single document in your entire collection just to find what you're asking for. Imagine flipping through every single page of a massive book just to find one little piece of information. An index lets the database skip all that and jump right to the good stuff.
So right off the bat, the first and most fundamental strategy is this. You got to create indexes that directly support your most common queries. Like, if you're constantly looking up users by their email, then you absolutely, positively need an index on that email field. It's really the ground floor of performance tuning.
Okay, so that's the perfect next question, right? Because just creating any old index isn't going to cut it. You have to create the right type of index for your specific queries. And usually, that boils down to two main flavors.
First up, you've got your single field index. Super simple, super clean. It's perfect for when your queries are just filtering on one thing. And then you've got its bigger sibling, the compound index. This is your go-to when you're filtering on multiple things at once, like finding all employees in a specific department who were hired after a certain date.
Making a single field index is actually super straightforward. Here, we're just telling MongoDB to create an index on the imp ID field. And that little 1 you see there? That just tells MongoDB to store the IDs in ascending order. Simple as that. From now on, any query looking for a specific imp ID, it's going to be blazing fast.
And a compound index. It's just as easy to create, but pay close attention to this example. We're indexing on imp ID first, and then on imp name. That order is absolutely critical. This index is going to be a rock star for queries filtering on imp ID by itself, or for queries that use both imp ID and imp name.
Okay, but wait a minute. Indexes aren't just for finding stuff. They have this whole other superpower, making your sort operations ridiculously fast.
Yeah, exactly. It's a classic problem, right? You find your documents in a flash, but then the database grinds to a halt doing this whole separate, super slow operation just to put them in order. That can be a massive performance killer, especially when you've got tons of results.
And this is where the magic happens. An index, by its very nature, already stores its data in a sorted order. This means MongoDB can just use the index. It completely skips that painful, slow sorting step. It literally just walks along the pre-sorted index and hands you the data exactly how you asked for it.
And here's something that's really cool. A single index can pull double duty. If you create an index in ascending order, like we just did for imp ID, MongoDB is clever enough to use that same index for descending sorts too. It just reads it backwards. How efficient is that?
All right, we've got the fundamentals down. Now let's level up. We're going to get into a couple of pro tips that can make a huge difference in your app's performance. Seriously, this is the stuff that separates the good from the great.
Okay, pro tip number 1, and you really need to remember this. Memory is everything. Reading from RAM is just orders of magnitude faster than pulling data from a physical disk. So if you can get your indexes to fit entirely in your server's RAM, MongoDB never has to touch that slow disk for its lookups. Honestly, this is probably the single biggest performance boost you can get.
So the obvious question is, how do I even know if my indexes fit? Well, MongoDB gives you a really simple command to check. You just run totalIndexSize on your collection.
And bam, it'll spit out the total size in bytes. So in this case, we're looking at about 49 kilobytes. Now you take this number and you compare it to your server's available RAM. It's a quick check to make sure your working set isn't causing a bunch of slow disk reads.
All right, our second pro tip is all about a concept called selectivity. Basically, a selective query is a smart query. It's one that uses an index to really narrow down the search. The whole goal is to make the database do as little work as possible.
Let me show you what I mean. Here's an example of a less selective query. Even if you have an index on imp ID, the database still has to scan this potentially massive range of entries, every single employee with an ID bigger than 1, just to find the ones who are also in India. That's a lot of work.
Now compare that to this query. This is what we call highly selective.
Because it's looking for an exact match on a field we've indexed, the database can use that index to go straight to the one single entry it needs to find the document. It is, without a doubt, the most efficient kind of query you can write.
Whew, okay. We have covered a ton of ground. So let's boil it all down into a simple checklist you can take with you and use to check out your own MongoDB indexing strategy.
All right, let's run through the 4 key takeaways. Ready? 1. Build the right tool for the job. Use a single field or a compound index to perfectly match your queries. 2. Don't forget that indexes are also your secret weapon for speeding up sorting. 3. And this one is huge for raw speed. Do whatever you can to make sure your active indexes fit snugly in RAM. And 4. Write smart, selective queries so that your database is doing the absolute minimum amount of work necessary.
So I want to leave you with this one question to think about for your own projects. Right now, is your indexing strategy an asset or is it actually a liability? Is it helping you fly or is it holding you back? A really well-planned indexing strategy, that is one of the most powerful tools in your entire toolkit.
And that's a wrap for this explainer. Hey, if you found this helpful and it cleared some things up, we'd love it if you hit that like button and subscribe for more. Thanks so much for hanging out, and we'll catch you in the next one.